Cool. So can you see my screen?
Yes.
Fantastic. Cool. Yeah, I'm definitely not going to be anywhere near as technical. So this is a slightly more kind of narrative driven talk. So I'm going to talk a little bit about our organization, Open Energy Labs. What we do is we are empowering people, particularly in sub-Saharan Africa, to build renewable electricity supplies. There we go. Cool. Obviously, energy access is a really big problem across the continent. There's still 600 million people without access to electricity in Africa. Across the world, that's 1.2 billion. A significant portion of the world don't have access to electricity. And through the Sustainable Development Goals, the UN and the various governments of the world have come together to drive towards 2030 being the year by which everyone should have access to secure, affordable, sustainable and modern energy. So we've got 9 years left to achieve this target, and progress has been pretty slow, particularly in sub-Saharan Africa. We're still looking like the number of people without access to electricity is set to increase due to population growth. There's still a lot of work to be done. Obviously, not having access to electricity has an impact across a vast range of different activities. Obviously, we've seen today around the impact that it can have on households when it comes to cooking with indoor air quality. Here, this image highlights education and the impact that it has there. Students who can't study after dark fall behind in school, or often have to rely on these kerosene lamps. Which are very polluting, dangerous. They fall over and cause fires. Not having access to that's on the lighting front. Not having access to electricity obviously impacts your ability to communicate. Mobile phones are rapidly increasing their penetration across the continent, but people are still having to travel large distances to charge their phones. People are having to travel into town or walk, 20 to 30 kilometers just to be able to find a power source to be able to charge their phone. So there's also kind of significant opportunity costs that come with not having access to electricity. So what we're trying to do is we're trying to solve that problem, and we're driving towards universal access to electricity across the continent. But what we're doing differently is we're trying to put education at the core of what we're doing. So rather than coming in and building solutions, what we're really trying to do is trying to teach people to build those solutions for themselves. So we're working predominantly in Zambia, and we're looking to we're targeting the 110,000 students that are there in Zambia. So that's across technical colleges and secondary schools. And we want all of those students to be building their own electricity supplies. Now, one of the things that we've also come to realize is that governments are a really important part of that. And so we've been working really closely with the Zambian government to try and maximize our impact. And we've got a fantastic team behind us. So as I mentioned, our aim is to make electricity available across the continent. So what we do is we teach people how to build and maintain renewable electricity supplies. But what we're really trying to do as part of that as well is support countries on the continent to become new centres of renewable energy research, innovation and design. And I think there's a lot of kind of conversations going on around leapfrogging and new technologies coming on, but particularly with solar energy becoming more and more of an important part of the energy mix, we think that there is a really strong potential for new innovations to come out of communities working in sub-Saharan Africa. However, there are still some barriers to be able to achieve that. So just a little bit about us. My name is Development. We've got a fantastic team on the ground with Granville, who is a Zambian, but also built his own robot out of old DVD motors. Yeah, which is quite a sight to behold. And we've got some fantastic people alongside that. So one of the key problems of electrification in Africa is the fact that there is very limited technical talent and technical capacity, not technical talent is the right word, capacity to build renewable energy systems. There is a whole bit of talent. Now, what we've seen is that within the particularly rural electrification has been a big problem because there's been a very heavy focus on grid-centered energy. So as on the left here, you can see we've taken a map of Zambia and have projected on the kind of main lines, the main kind of grid lines, and you can see they kind of follow these population centers. So once you move into these rural areas, that's really where you don't find access to electricity. And you know, rural electrification in Zambia still stands at 4%. And it's taken 12 years to increase that by 1%. So 12 years ago, it was at 3%, now it's at 4%. And, you know, as we've kind of moved towards more decentralized energy, particularly with solar power, what we've also seen is that there's been a need for a really significant shift in the types of skills that people need in order to build those sorts of solutions. So at the moment, all of the engineers that we've been interacting that exist within the Zambian government, it's still a state-owned energy company, they're all trained and all of their skills are within kind of large-scale grid electrification, whereas what we're seeing now is there are a whole load of companies coming in delivering decentralized renewable energy, but they're based in the UK, based in Europe, based in America, and they're then bringing all of these skills, in particular looking at kind of software development, which is becoming increasingly important in the energy sector, as well as electronics and embedded software engineering, which are skills that at the moment you really don't find within Zambia. So in order to solve this problem, we've created something called Energy Makers Academy, which teaches students how to build solar systems which are able to provide reliable power. And we do this through a high-impact, low-cost learning platform with the aim of empowering communities to build and fix energy systems. Now, before I show you guys Energy Makers Academy, I just want to kind of tell a little bit of a story of how we got to where we are today, just to show the kind of process of innovation that we've kind of been through. So our first prototype was something called the LE1. And the idea that we had with that was that you could take anything that generated electricity and use that to charge mobile phones, lighting, power banks, etc. So what we had is we had this literal black box, which you could hook up an old motor. So this is an old motor from a blender, and then you could find a way of turning that motor. So here we've got a little hand crank. I'll show a little video of this working later. And that would then take the electricity from that and turn it into USB power, which you could then use for lighting or to charge a power bank or a mobile phone. And the concept there is that if you put a voltage across a motor, it will spin, but equally, if you spin a motor, it will actually generate a voltage. So what we were doing, we were providing people with those sorts of tools, but we were also trying to provide feedback. So you can't quite see it here, but there's a little screen there, and you'll get to see that in the video in a second, that was providing feedback so that when people were creating their designs, whether they were using hand cranks, which you can see here was designed by people in our workshop, but whether they wanted to attach that to bicycles or whatever, that would then allow them to get feedback on how well their designs were performing, and they could then use that to innovate and create better energy systems. And that was always, gearing towards being able to charge mobile phones and provide lighting. So we went out and we tested this. So these are some of the workshops that we ran. As you can see here, this is the gentleman who came up with the design earlier. So we had a wood workshop in Tanzania. And within Tanzania, we also provided some very simple designs for a wind turbine. So this is actually a wind turbine made out of PVC pipes, and you can see here on the right hand side, you can see these are some of the wind turbines. Now, I should stress, we didn't design these wind turbines. We showed people how to build the blades, but beyond that, all of the designs here were all designed locally, using materials that we didn't even really know were there. We showed them how to design the blades, and then all of a sudden, all of these materials just kind of started turning up. So it was really kind of amazing to see, with that kind of initial little bit of knowledge, that people were able to build on that really quickly and iterate and create new solutions. But what we quickly found was that with this being a literal black box, people were saying, listen, we really love the kind of wind turbines that we built, but what we really want to know is actually, how does that thing work? Because quite often people were buying these solar home systems and they were breaking after 6 months. Sometimes they were basically dead on arrival, and people didn't know how to fix them. And so we said, okay, that's really interesting. So what we decided to do was we decided to open them up and show them a little bit how exactly they worked. And so you can see here on the left, this was our kind of our first attempt to kind of say, okay, well, this is how you assemble it. And we did some work on electronics. And then after that, we ran some further workshops where we were taking this that black box and opening it up for people and trying to teach them the kind of fundamentals of electronics so that they could actually build that themselves. And so from that, we took that black box and essentially made it educational. And this was something called the LE1. And it's what we think is the world's first learnable charge controller. So what it did is it taught students circuit theory, design, electrical engineering, soldering, a little bit of programming. And the way in which we did this is we designed a printed circuit board, which broke each of the individual sections of a solar charge controller into these individual sections, and allowed students to go through a process of actually building those the charge controller. So a really important part of this was the fact that we really wanted it to be made from locally available components. So all of the components, apart from one or two, you can actually source locally. So there's these amazing electronics markets that we found in Zambia, where you could buy a vast array of electronics, and pretty much all of the components on here you can actually buy within Zambia, with the idea being that of course these things after time can fail, particularly capacitors and resistors, they kind of have a lifetime. So being able to provide people with the skills that they need to actually fix these was really important to us, and has a whole load of benefits, like reducing solar e-waste, which is an increasing waste stream, but also kind of trying to foster innovation within those communities. So here's a very quick video. We'll see if this goes ahead, just so that you can see how this works. Here we go. Cool. So as I mentioned, we've got a couple of kind of key components here. So we have a recycled motor, so that then hooked up to the LE1, and then you had a USB output. So that recycled motor, this one's actually from a blender, but it could come from a ceiling fan, from drills, and then you just had to find a way to spin it, and that would then start generating electricity. So as you can see, this is, the hand crank here is essentially just, that's just junk. that's a gas mains T. And you could then use that to build wind turbines, or maybe you could attach it to a bicycle. And so here again, we were providing feedback that allowed people to assess how well their innovations were working. Here we go. No, that's not what I want. Here we go. Cool. Following using the LE1, we trained 100 students using this. We had about 900 students on our waiting list, and we engaged 9 government departments, including the Department of Energy and the the Ministry of Higher Education as well. And we made a real effort to have 50-50 recruitment when it came to engaging women as well as men. For this round, we actually managed that. So we had 50-50 student recruitment. We ran women-only workshops, which was a really important part of what we were doing. And this is Teaser, who is now developing a wind turbine that uses the gusts from cars as they pass by a motorway to generate electricity to charge mobile phones at bus stops. And that was a kind of direct outcome from our workshops. Before I move on, now, as you can see here, everyone is using laptops. And that was a major barrier for people, particularly in rural areas. And it was also something that made our program really scalable, made it difficult to scale our program because we weren't able to actually deliver this in any way other than in person. And so we decided to develop a mobile phone app that would allow us to deliver the educational content that we had been kind of using up to that point, and also to allow students to use their phones to actually write some software as well. Off the back of this, we developed our current project, which is Energy Makers Academy. And as I mentioned, this delivers a whole load of learning content. So we've got 14 modules, and I'll give you a quick demo in a video in a second. And we provide that as a hardware kit, so it comes with all the components. Again, we've made a really big effort to make sure that all of the components can be sourced within Zambia. And what's really cool is that this now allows us to connect to our hardware. So when we actually allow students to write software for their energy systems, and we'll see a little bit about that in a second. And of course, you can use that to charge your phone. Here we go. So this is a quick video demonstration of Energy Makers Academy. So again, you can charge your phone. So one thing I should mention, whoops, that's the one. So one thing I should mention is that when we move towards these charge controllers, what we quickly realized was that, people really wanted to see, really wanted to be using solar. I think that when we went and supported people to build wind turbines, it was a really fun project, and they had a great time and learned a lot about energy. But solar was definitely the dominant energy source, so we've kind of switched to relying solely on solar. In this example, I'm just using a very basic 9-volt battery. There's not much sunshine in the UK, and that then allows you to charge your phone. Of course, we've got all of this learning content. So within the app, you can learn about the fundamentals of electronics. Here we're teaching people about how to measure voltage, how that sits within a circuit, using a multimeter, and that. What we also do is we also teach students how to write code. So within the app, we have a block-based programming language based on Scratch. And that then allows students to actually write code, which they can then use to manipulate things on the board. So here's just, I'm going to be opening a very simple example where we're just going to be writing and changing this so that we can change this little LED here. So fundamental programming concepts are explained, and then that actually allows you to see what exactly it is that you're doing on the board as well. Now, it's not just LEDs that you want to be controlling, you actually want to be controlling the power that you have on the board. So here we have a little USB light hooked up to the output. And so when we change things in the software, we're actually able to control that. Of course, a really important part of writing any sort of control system is being able to measure things. So here we're actually able to measure the voltage of the battery, and that then allows us to write code and make simple decisions. So, for example, one of the things that allows us to do is it allows us to support students who want to develop new ways of generating electricity or managing electricity. So, for example, in a recent pilot, students, one of the concerns was human-animal conflict. And so that means that hippos were coming in, eating the crops, and coming into conflict with humans. And that then led to injuries and some deaths as well. And so students were using the actual platform in order to create new ways of generating and managing electricity by creating devices that were monitoring the crops and then switching on lights, creating loud noises, so that when animals came to the crops, they were then being kind of scared away. Since we've launched Energy Makers Academy, we have been prototyping this. We've worked together with 4 delivery partners. We have some very, very happy students. And so far we've trained 50 students. We're going to be doing a full launch in October, where we're going to be working together with technical colleges and universities across Zambia, as well as working with other organizations who are working closely with communities, such as tour operators, who have kind of lodges and working with the communities around them. So what does all of this actually mean? What are we actually doing? Why are we doing all of this? So we are working together with the Ministry of Higher Education and the Ministry of Energy to incorporate this educational kit into the secondary school curriculum. So that means that rather than just learning from a blackboard, students will actually be able to get hands-on experience of building and repairing household electricity supplies, and through that learning about electricity and giving them the skills that they need in order to solve that problem of renewable energy access. So by 2030, we're looking to have 500,000 students in Zambia with a basic understanding and ability to repair a solar home system, looking to drive access to information, education, jobs, entrepreneurship, and, as we've heard before, improving health as well. Of course, access to energy in particular, access to education is a big problem, particularly for women in Zambia. And so what we've been able to do is drive more of this kind of remote training model. So students are able to just get the smartphone app and the kit, and then are able to learn at home at their own pace, meaning that rather than having to travel to a particular on-site place, they're actually able to engage with this program as well. So yeah, trying to get more women and girls involved in electronics, and particularly in rural regions is what we're driving towards. So as I mentioned, we've been working with the Ministry of Energy. These are some of the partners we've been supported by: EPSRC through the Global Challenges Research Fund, DFID, of course the FCDO now, and Innovate UK. And we've got some fantastic partners in Zambia, working with the National Science and Technology Council, National Technology and Business Centre, and Energy for Impact, who are working in the energy space in Sub-Saharan Africa. So that's us. Please feel free to get in touch. openenergylabs.co is our website, and that's my email address as well.